Hello everyone and welcome back to the next video of the algebra category in mathematics, 1.3, lines. In this section we're going to be talking about different types of lines that you could have and the ways you could kind of figure out questions that you would be asked on an exam or homework, certain things about lines. There are 6 sections and there's 6 subsections in this section, which we're going to be covering. The first one we're going to be covering up is the slope of a line, the point slope form, the slope intercept form, the vertical and horizontal lines, the general equation, and the parallel and perpendicular lines. So in this section, we're going to be talking about how to relate these and how do we solve for certain problems in order to figure out what the question is asking for. I'm sure you guys have heard these terminologies before of some sort. So this is just kind of a section to kind of relearn and try to see what's up in order for us to try to figure out what they're asking us to do in either your homework or your exams coming up. Alrighty, so the first section we're going to be talking about is the slope of a line. So what is the slope of a line? Usually there's a variable we call that, and usually we based it off as m. So some type of m, you'll see that a lot in, on the textbooks and such. But usually what m means in terms of a slope of a line means rise over run. Or if you have 2 points, you would usually find the slope by using those 2 points, using y2 minus y1 all over x2 minus x1. And usually when it comes to a diagram, the way you will kind of see it in a picture over here on the diagram is that when you have a diagram like this, a y and x, if you have a line, let's say you have a line, and let's say you're trying to figure out, or they're asking you to figure out the slope of that line, you get 2 points in that line, right? It doesn't matter what the points are. As long as you're in the line, you pick those 2 points, and you try to solve, finding the slope by using this, the y2 minus y1, all over x2 minus x1. And here, we have point A and point B, and what we do here is that when we rise, we go up, since that's the first thing that goes up, and then we go run. So we go either right. In this case, we go right to run. Rise could either go up or down depending on how the diagram looks. And run could either be left to right depending on where the line goes to. Which is why when it comes to rise, we focus on our y's. And when it's asking us to run, we always focus on our x. Yeah, but that is what it means for a slope of a line. Here are different types of slopes that you might encounter in your classes, homework, or whatever you see in your math. You might see a slope which we end up calling a positive slope, right? Usually kind of think of that like, let's say you have a line, right? Let's say you have this line, right? I highlighted right there. And let's say you're going upwards. Let's say you are on a roller coaster of some sort, and you're going, if you see that they're going up, that means that you're going to have a positive slope. But what about negative slope? So let's say here for number 2, you do have a negative slope, right? So you're going down. You're declining, right? So that means that if you have that line as a diagram, you are going to have a negative slope. There are going to be instances that you're going to have a 0 slope or a no slope at all. And the way you figure those out when it comes to either an equation or a diagram is by there. So for number 3, let's say that you have a line like straight like this, right? That is what we call a 0 slope, meaning the slope of that line is 0, no matter what, because that is a straight line. And then for number 4, let's say that you have a line that just goes up and down, right? Straight, up and down, right? That is what we call a no slope. You're not going up, you're not going down, it's just straight down, like literally. There's no inclination of some sort, which is why we call that a no slope. And like I said, we're going to be doing different problems so you guys are kind of related into when you'll get a 0 slope or a no slope or positive or negative. So yeah, so just keep tuning in. Now we're going to be talking about the point slope form and the slope intercept form. As you guys can see here for the point slope form, we have a formula. And this is a formula. Y minus y1 equals m parentheses x minus x1. As you guys can see here, what does x1 and y1 mean, right? That is any point in the line. It doesn't matter what point it is, again, as long as it's in the line. If you're going to pick that point in the line, you are able to figure out the point slope form using that information you have. And again, don't forget that the m here stands for slope. That always means that, okay? And then for the slope-intercept form, you have y equals mx plus b. Here, m is slope again. X stays as it is, meaning that x, you don't touch it. This means that it's next to that slope, and it's a variable. And then you have a plus b here. That b doesn't really stand so much of like the information you have. It just tells you how high or how low the graph is in terms of your y-intercepts. Right now, like I said, it's just me kind of saying it, but when we do a problem, you'll see what b stands for. So yeah, so these two formulas are really important, so just keep that in mind. So let's do a problem together. So let's say they're asking you, find the slope-intercept form through the point 1, -3 with the slope of -1/2. So let's put the pieces that we have, and let's try to figure out the pieces that we don't not have. For the slope, we have -1/2. Cool. But what about the point? We do have a point. We only have one though. It's a point 1, -3. So with this information, they're asking us to solve it for the slope-intercept form, which we know from the last slide is that is y equals mx plus b, right? But here's the problem. How do we use these two to figure out that sort of formula? There's something that we also did before in the last slide, which we did the point slope formula. And the point slope formula, if you guys recall, is y minus y1 equals m parentheses, sorry, x1, and all that. So this formula is going to help us in order for us to create that slope-intercept form that they're asking us to do. So you just plug in the pieces. So y stays the same, minus y1. What is y1 in this case? Is -3 equals m, which is -1/2, x minus 1. Okay, so we figure out the right-hand side first. Doesn't really matter. You could do the right or left. We know that the left-hand side is y plus 3 because we do have two negatives to each other, which kind of create a positive. And then we have -1/2 x plus 1/2. Now, since this is a form and we know that the slope-intercept form, y is by itself, so we just solve for y. So we bring the -3 to the right-hand side, which we get y equals -1/2 x plus 1/2 minus 3. And then we combine like terms. So going back to your algebra skills, here's important. We need to figure out the common denominator, right? The LCD. And we know that the LCD for this case is 2. Since we do have a denominator of 2, so we need to have that at 2 as well. So what we do is that we multiply that top and bottom by 2. So you'll get y equals -1/2 x plus 1/2 minus 6/2. So what I did here is that I multiplied 3 times 2 over 2 to the top and bottom since our LCD is 2. So we have y equals -1/2 x minus 5/2. And does this look like the slope-intercept form? It does. Yeah, so we already found our answer. So it's y equals -1/2 x minus 5/2, which is your slope-intercept form for this problem. Like I said, if you don't have all the tools for the slope-intercept form like right off the bat, we are able to kind of come up with an answer using the point slope, which is why I said that the point slope always comes before the slope-intercept form, which is why both formulas are really important to know when it comes to trying to figure out lines. We do have another example though, so don't worry. Find the slope-intercept form. Again, they're asking us to find that form through the points -1/2 and 3 to -4. Sweet. So we know that the slope-intercept form, again, is y equals mx plus b. And we are given 2 points. Point 1 is -1/2. And point 2 is 3, -4. But here's the thing. On the slope-intercept form, we have m. We do not have m right off the bat here. But are we able to solve for it? Yes, we can. Remember how in the first slide we talked about what is slope and what is the equation for that? M equals y2 minus y1 all over x2 minus x1. You at least need to have 2 points to figure out the slope in this case. And we do have 2 points. Point 1 and point 2. So you just plug them in. Remember, this is x1 comma y1, and this is x2 comma y2. Yeah, so you just plug in the numbers into the slope. So y2 is -4, and then y1 is -2. Because remember, it's y2 minus y1. And then x2 is 3 minus x1, which is -1. Which it's -6 all over 4. So our slope for this particular problem is -3/2. Sweet. So we have m, we have a point. Well, we have 2 points in this case. So are we able to now solve for the slope intercept? Yes. But before we get there, we got to figure out how to get there. Which then we use, going back, we use the point slope formula. Which I have now on the screen on red. So now we just plug in our missing terms. Now, you might be thinking here, we have x1 and y1 when it comes to the point slope. Are we able to pick any of these 2 points that you see here, point 1 and point 2? Can we use either or? Yes. No matter what point you choose, you're going to end up having the same formula, the same slope-intercept form, because they're both on the same line. It doesn't matter what point you choose. They both mean the same thing. So in this case, I'm just going to choose point 1. It doesn't really matter. I could have choose point 2. We'll still get the same answer. So we just plug that information into the formula. So we have y minus 2 equals -3/2 x minus -1. So we have y minus 2 equals -3/2 x, and then plus 3/2. No, actually, no. Minus 3/2. Yeah, so now we bring the -2 to the right-hand side, which we get y equals -3/2 x minus 3/2 plus 2. And going back, we got to find the same LCD. And the LCD for this case is 2. So we're going to have, on the next slide, we're going to have, oh, it's already on the other one. But here, let me make some space here. Make some space here so you guys can see what I'm talking about. So we know that the LCD in this case is 2. So we're going to have y equals -3/2 x minus 3/2 plus 4/2. That's a 3, sorry. So our final answer should be -3/2 x plus 1/2 as our slope-intercept form, which is what we're looking for. But yeah, with this in mind, this is going to be our last example for this particular subsections. So on the next one, we're going to be talking about what was on the other side, how to figure out if it's a no slope or a slope at 0. We're going to give you some examples of that. So thank you for tuning in for this section. The next one should come up on the next day, and hopefully you guys have an amazing day. Thank you guys for watching.